x squared. Now I realize if you're new to the power rule, you just lost me because you don't know what I'm doing yet. But what I'm doing, the steps that you don't understand yet, those of you who are new to this, who haven't taken calculus before, all I'm doing is just repeatedly using that power rule I stated earlier today and the additivity.
Why didn't you use the power rule for the x plus x?
I did. I used the power rule. I used n equals to 2 to do this. See this? Is that, right?
And what about x plus x cubed?
This terms right here are these terms right here.
So you don't change it.
The derivative of x is 1. The derivative of x cubed is 3x squared.
Yeah, the other one. The other x.
These other terms are not being differentiated.
Okay.
That's part of the quotient rule says you differentiate the top, multiply by the bottom, subtract the top times the derivative of the bottom. Okay, so at this point, it is time for me to give you guys a couple of examples to chew on before you chew on your cookie. Let's see here. Sorry, that was not intentional. So let's see here. You guys see if you can't calculate the derivative of x plus 3 divided by the square root of x and I should have left that up there. Oh well. How about this one? Another example. How about the derivative with respect to x of 1 over x plus 3 quantity squared? Let's see here. Just to make sure you don't get bored. Derivative with respect to x of, let's see here, x cubed over 3 minus x. I think with that, it should give me time. Thank you. I'll be right back. If I have my keys. Is the Did I turn the audio back on right? It's still bouncing? Okay, cool.
You're so nice.
Okay. So I let you guys. I have chocolate chip and I have white macadamia nuts. We have to open the chocolate chip. Someone may have partaken in a couple of the other ones before we got to here somehow. So here. Come on. So if you want to, I'll just let you take whichever one you want and pass it around. Just take which one you want and pass it around. I'll let you guys. Maybe the guys in the back row come up and get theirs if you want. Otherwise, it's going to take too long.
Take them really, really slow.
Oh.
I appreciate that.
These were actually for my Calculus 3, but then I changed my mind. Ha ha ha.
What did they do?
They keep asking me what's on the test. It makes me angry.
So, can you take it really, really slow? Like, slow down on teaching everything?
Take it slow.
You are?
What?
I'm just asking, like, could you take things more slowly? Because regularly when you're on that, I'm over here working on the other stuff. I'm talking when there was something there, not 1, 2, and 3. Like when you were working on that. I'm probably going to stay after for a second, so you could maybe do that again.
Well, you can always ask me questions to slow me down. I mean, I'm intentionally going slightly faster today because I want to get through, at least show everybody these rules, but we have all of next class to unravel it, so. Quotient rule, I think, is the way to go here. So the first one we do, we derivative of the top times the square root of x minus x plus 3 times the derivative with respect to x of the square root of x, all divided by the square root of x squared. Okay, so how does that simplify? So that's just square root of x, because 1 times the square root of x is just square root of x, minus x plus 3 parentheses times 1 over 2 times the square root of x. And if I said differentiate, don't simplify, we'd be done. If I said simplify, I don't know. If I wanted to simplify, I guess my pet peeve with this expression is that it's got a fraction of fractions. So I'd want to get rid of that. And so I'd multiply the top and the bottom by square root of x, which would give me x minus x plus 3 times a half divided by x squared of x. That would be my, and I could simplify that further, right? That's really 1 half x minus 3 halves divided by x squared of x. And then I guess if I really wanted to be honest there, that would be x minus 3 over 2 times x squared of x. And I guess that to me would be simple. But I don't know, to each his own. I like what's in purple. It's fine. WebAssign should count all of these correct, because WebAssign actually will run your answer against a computer algebra system. So if it's logically equivalent to the right answer, it should count it right. It's not like my math lab, which works on a question pool. Yeah.
The other way, it looks the same, roughly.
Oh. Yeah. No, he's right. I made this too easy. The gentleman is right. We could have, in fact, if I had half a brain, I would have done it this way. This is x to the minus 1/2 plus 3x to the minus 1/2, which is minus 1/2 x to the minus 3/2 minus 3/2 x to the minus. Oh, I'm an idiot. That's 1/2. Yeah, you should be confused. It was wrong. I mean, this is the other way you could do it. I'm sorry. Yes, I would. For some reason, I didn't see it. Idiot. This one allows the other algebra. Like, this one doesn't, though. So what would you do here if you don't know the chain rule? All right. Sad. Yeah, if you know the chain rule, you're welcome to use it, but that's not my intention that you have to use it, okay? So that probably means this is a bad problem for the test. But so what we do is derivative with respect to x of 1 times x squared plus 6x plus 9 minus 1 times the derivative with respect to x of x squared plus 6x plus 9, all divided by x squared plus 6x plus 9 quantity squared. What's the derivative of 1? Of course, this is just 0, right? So really, you just have minus parentheses 2x plus 6 divided by x squared plus 6x plus 9 quantity squared.
Where'd you get 2x plus 6?
I differentiated this right here. That gives me these terms. That is true. But the yes, good job. Oh, now I can't say it. I would hope, yes, it is true, sometimes I will skip a step. And if I do that, it's partly an invitation for you to fill them in. So, yeah, I know. So here's the steps I was skipping. Because this is 0, of course. It is a constant, so.
Oh, I see now.
If we differentiate a number, it's 0. I mean,
A number comes out to 0.
Numbers do not change. So when we differentiate a number, it doesn't change. Yeah.
It goes 0.
And the other one, okay, yeah, 0 divided by 0.
Shall I do the other one? Oh, I'm out of time. So if you guys remind me, I'll do this start of next class, okay?
All right.
So
Could you
Real
you can.